Hey there, students. Welcome to the TrU Unit 1 test review. We're going to be doing the some questions to get you ready for the first test, okay? All right, so let's go ahead and take a look at question number 1. Question 1, oh, it says, what are the solutions to the equation 4b squared plus 8b plus 6 equals 0, okay? Now, if you take a look at this equation, the question is it reducible? Can I reduce every single term by a constant? If you take a look at 4, 8, and 6, you notice that they have 2 in common, okay? So you can basically reduce this equation by dividing everything by 2 because 2 is a common factor. So to do that, I'll divide the first, second, and third term on the left side by 2, and then on the right side, divide that constant by 2. Alright, if I do that, I'm going to end up with 2b squared plus 4b plus 3 equals 0. Okay? Now let's go ahead and solve this. Let's try and use the factoring by grouping or the XA method first, and then if that doesn't work, we can try another method. Okay, so let's make our x on the right side. Remember, AC goes on top and B goes on the bottom. Alright, so AC on the top, B on the bottom. AC is 6, B is 4. Alright, so 1 multiples of 6 can combine to give us 4. Well, let's make a list of the factors of 6 and see which one generates 4. Okay, so 6, I know 1 times 6 is 6, and then 2 times 3 is 6. Alright, and then we have a complete list. Now 2 and 3 generates 1 or 5. 1 and 6 generates 7 or 5. Neither of them can generate 4. So that means that this quadratic is prime, hence it cannot be factored. Alright, so since the factoring method doesn't work, now we have to resort to the quadratic formula. Okay, so the quadratic formula basically is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, now in this problem we know that a is 2, a right there, b is 4, and c is 3. Remember that before you determine a, b, and c, your quadratic has to be in standard form, namely degrees in descending order equal to 0, and that's the case here. Alright? Okay, now let's plug in these values into a quadratic formula and go ahead and solve it. So we have x equals negative 4 plus or minus the square root of b squared, it's 4 squared, minus 4ac, 2 times 3, and then that whole story divided by 2a. 2a is going to be 2 times 2. Alright, now let's go ahead and simplify that. We're going to have negative 4 plus or minus the square root of 4 squared 16. 4 times 2 is 8. 8 times 2 is 24. Divided by 4. Okay? And that becomes negative 4 plus or minus 16 minus 24 is negative 8. So square root of negative 8 over 4. Okay? Now remember, anytime you take the square root of a negative number, it becomes I, because the square root, remember the square root of negative 1 is I, right? So this minus is going to come out of the radical as an I, but we also have to reduce rad 8. Okay, so let's do that on the left side here. What's the square root of 8? We know the minus comes out as an I. How about the 8? Let's break it down. 2 times 4, and then 2 times 2. These two 2's repeat, so they can break out as 1. And the other 2 stays under the radical sign, right? So this whole expression becomes 2i root 2. Okay, so it's going to become, this 2's break out as a 2. This minus comes out as an I. And this 2 stays behind because it's by itself, stays under the radical sign because it's by itself, okay? So there goes the the simplification of the radical roots negative 8, okay? So this becomes negative 4 plus or minus 2I root 2 over 4. Okay? Now to reduce the fraction without making mistakes, I advise you to split it apart. So we're going to split it apart. We're going to have negative 4 over 4 plus or minus 2I root 2 over 4. Okay? So this part here we can divide by 4 top and bottom. That gives us negative 1. And this one 2 goes here once and 2 goes here twice. So plus or minus I root 2 over 2. So the answers are, let's split them apart. Negative 1 minus I root 2 over 2 and negative 1 plus I root 2 over 2. And there you go. There goes your answer. Alright? Okay. Alright, so let's move on to question number 2. Alright, so this one is a factorization problem. So let's hear the problem. Factor the expression x plus 3 square minus 9y squared. Okay? So if you take a look at this, this is just like a difference of squares. It might look a little bit more complicated, but it's nothing more than a difference of squares. You have a square here, and then you have another square. So you remember the formula for factoring difference of squares. You have a squared minus b squared. It factors into, you take the square root of the first and the last, you add and subtract the square root. So a plus b times a minus b. Okay? Remember the square root and the squares cancel out, so the inverse operations, so you just left with a and b. Alright, if I apply that procedure here, I'm going to take the square root of the first square and the second square, and I'm going to add and subtract the square roots. Okay? So this square cancels out with the square root cancels out with this square, the square root cancels out with this square, but the square root of 9 is 3, so we're going to be careful with that. So we're going to have the sum, which is x plus 3 plus 3y, and then the difference, which is x plus 3 minus 3y. Okay? If this system is a little bit too confusing for you, you can just put it on the side, and then for a, just take the square root of x plus 3 squared, which is x plus 3. And then for b, you take the square root of 9y squared, which is 3y. And then just add and subtract these two square roots, and that gives you your final result. Alright? Okay, now let's move on to question number 4. Alright, so for question 3, let's try this problem. Number 3, how about you ask to factor z minus 2 square minus y squared. Okay? This is a difference of squares problem again, just like the initial one. So if I want to factor this, I'll just take the square root of the first term and the last term, add and subtract the square roots. Okay, so we're going to have the square root is going to be z minus 2 is the square root of the first term, because the square root and the square cancel out. Z minus 2 plus the square root of y squared is simply y, so there goes the plus component, and then the minus component, you have z minus 2 minus y. Okay, so we're using this same formula to solve this problem. Alright, moving right along, let's try out question number 4. For question 4, we have the following problem. It's a factorization problem. So for this one, I'm going to factor the expression 3w squared z plus 6wz minus 24z. Okay, so this is what we're factoring. So before we start, what we're going to do first is we're going to break down the whole expression to see if I can extract a common factor. So I'm going to have 3 times w times z. If I break down 6, I have 3 times 2 times w times z. And then 24 is a little bit difficult to break down, so let's put it on the side. So I'll take out 2, 12, 2, 6, and then 2, 3. So 24 is basically 2 times 2 times 2 times 3, and we have the z. Alright, let's examine all three terms and see if we can pull out a common factor. 3 is common with all three of them, and z is also common, so we're going to extract 3z. Alright, so we're going to have 3z times w squared plus 2w minus 8. Okay? Now let's focus our attention on factoring the trinomial here. So since we have a trinomial, we want to use the x game to make it into 4 terms, so we can factor by grouping. Okay? So let's go ahead and make our x on the right side. AC goes on the top. In this case, AC is negative 8 and B is 2. Okay? There's a 1 here for the coefficient of A, and we multiply 1 by negative 8. The answer is negative 8. Okay? Alright, so let's see what works. To generate 8, 1 times 8 is 8. 2 times 4 is 8. And, okay, so 2, 4, we have a complete list. Now, let's see, what combination can generate 2 from this list? So we know 2 and 4 can generate 2, so let's put it here. 2 and 4, it doesn't matter the order that you write it in, you still get the same answer. Since the sum is positive and the product is negative, that means the smaller number has to be negative. Okay, so let's insert that back into this expression in the parentheses. So we're going to have 3z times w squared minus 2w plus 4w minus 8. Okay, now we have 4 terms we can now factor by grouping, so we're going to split down our expression down the center, and then let's break it down. We're going to have still 3z on the outside, and then we have w times w minus 2 times w plus, and then break down 4 into 2 times w minus 2 times 2 times 2. Okay? Alright, now let's start factoring by grouping. We have 3z. Now from the first 2 terms, we can take out w because it's common. So we factor out w, and then we're left with w minus 2. Always bring down the middle sign, and then from these 2 you can factor out 2 2's. 2 2's, if you multiply them together, you get 4. Okay? And then 4w minus 2 goes down. To check to see if our work is correct, these 2 quantities have to be the same. They are, so that's excellent. So we have 3z times w minus 2, and then the stuff on the outside, w and positive 4, you bring them together, w plus 4, and there goes your final answer. Okay? Alright, so there goes the factor form. Now let's move on to question number 5. Problem 5, we are going to evaluate an expression. So evaluate the expression x squared plus 6x divided by x plus 7 times x squared minus 49 divided by x squared minus x minus 42. Okay? Alright, so with that in mind, we are going to factor them term by term and then see if we can cancel out any common factors, because I don't know if this has any common factor with the denominator or this term has any common factor with the denominator. So we're going to extract them term by term and then factor them as much as we can. Alright, so let's start with the top left with the numerator on the left. So left numerator. So the left numerator is x squared plus 6x. So we're going to break it down. We have x times x plus 2 times 3 times x. Alright, so what can I factor out from here? I can factor out an x, so I take out an x, and I'll be left with x plus 6. Okay? Alright, so let's reinsert it back. So in the left numerator, we have x times x plus 6. Now if we look at the denominator on the left, this cannot be reduced. It's simply x plus 7. It's a linear, and this has nothing in common with 7, alright? Now let's shift our attention to the numerator on the right, so the right numerator, alright? I'm going to erase this so I don't keep scrolling up and down. So the right numerator, the right numerator is basically x squared minus 49. If you examine this, you notice you have a square and a difference sign, so this is a difference of square. So we apply the formula for factoring difference of squares. You root the first and the last, and then you add and subtract the square roots. Okay, so we're going to have x plus the square root of 49, which is 7, times x minus the square root of 49, which is 7. Okay, so that goes on the numerator on the right. So we're going to have x plus 7 times x minus 7. Now let's go ahead and factor the denominator on the right. Okay, so right denominator. If you take a look at the right denominator, you notice that this is a quadratic trinomial. So we need to factor this using the x game. Okay, so we have the quadratic trinomial x squared minus x minus 42. Let's see, can I factor out anything from all three terms? All three terms? I can't, right? Just to show you, I'll need to break everything down. X times x minus 42. We can break down 42 into 2 times 21, and 21 is 7 times 3. So it's 2 times 7 times 3. 2 times 7 times 3. You can clearly see that nothing is common to be factored out, right? So we're going to reassemble it just as it was initially. So we have x squared minus x minus 42. Okay? Now we're going to use the x game to finish this up. So what we'll do is we'll make our x. AC goes on the top, and then B goes on the bottom. AC is negative 42, and B is negative 1. Alright? So let's go ahead and make our list of factors for 42 and see which of them would generate 1. Alright, so for 42 we have 1 times 42, 2 times 21, and then 3 times 14. 3 times 14 gives you 42 also, and then we have 6 times 7. Okay, so there goes a complete list. Alright, so let's see which of these combinations can give us negative 1. We can clearly see that the last pair gives us negative 1. So 6 and 7, since the sum is negative, that means the bigger one is going to be negative, alright? So we're going to rewrite it as x squared plus 6x minus 7x minus 42. And then we have 4 terms now. We can now factor by grouping, break it down the center. Alright, so let's break everything down. From the first one, we have x times x plus 2 times 3 times x minus 7 times x, and then 42. We broke it down here before, which is 2 times 7 times 3. Okay? Alright, so from the first two, I can extract an x. X is common. So we take out an x, and we're left with x plus 6. And then from the last two, I can take out negative 7. It's common there. So I take out negative 7, and I'm left with x plus 6. Notice how the sign changed? Because I factor out a minus from a minus, so it has to become the opposite. Alright? These two quantities are the same, so I factor them together. So 6 times x minus 7. So there goes the factorization of the denominator on the right. Okay? So let's reinsert that back into the equation. So we have x plus 6 times x minus 7. Okay? Now we're going to reduce. Remember, you can reduce anything on the top with anything on the bottom across, but you can't reduce anything in a horizontal direction. Only across or down or across. Okay? So let's reduce. Let's see. X plus 7 goes into itself once, and it goes into this top expression here once. What else? X plus 6 goes into itself once and goes into this term once. So we can reduce across or downwards. Oh, see this? pair, we can reduce downward. So x minus 7 goes here once, and x minus 7 goes here once. So if you multiply the numerator across, it's x times 1 times 1 times 1. This is x over 1 in the denominator. The final answer is simply x. Okay? So there you have it. Alright, let's move on to question number 10. We're going to be graphing complex numbers. Plot -1 minus 4i. Alright? So how do you graph a complex number of this nature? Well, it's not that complicated. Just think of the real part as the x-coordinate and the imaginary part as your y-coordinate. Okay, so what we're basically graphing is we're going to plot -1, comma, -4. Can you graph this point? Absolutely. Right? It's nothing complicated with graphing points. So make a coordinate system. It's going to be a third quadrant. So what we do is just graph the x and the y. The x is -1 and the y is -4. 1, 2, 3, 4. Bam. So there goes the graph of -1 minus 4. Alright, so this is your imaginary axis and this is your real axis right there. Okay. Alright, let's take a look at the last problem that has to do with the transformation of quadratic functions. So this is I don't know why I jumped to 10, but this is question number 7. So number 7, we're supposed to describe the shifts. Describe the shifts of the quadratic. Shifts of the quadratic y equals x plus 2 squared plus 3 to y equals x minus 1 squared plus 4. Okay, so we're shifting from here to here. So how can we describe the shifts? Notice the widths are the same because you have 1 as a. So to describe the shifts, what we're going to do is just simplify the vertex, grab the vertices, and then we're going to see how we can get from one vertex to the next. Okay? So what's the vertex of the first function? This is our start, that's our start. The vertex of the origin graph is, you take the opposite of the number next to the x, which is -2, and then just bring down this number right there. This is in the vertex form. 2, take the opposite of this number, -1, and then you just bring down that number 4. Okay? Alright. Now, we're going to go ahead and graph these two functions, graph these 2 points, and then we can use the shifts in the vertex to basically summarize what shifts happen with the whole quadratic function. Okay? Alright, so -2, 3. Let's graph the starting point, -2, 3. So to graph that, this is the y and x axis. We're going to go 1, 2, 3, -2, and go up 1, 2, 3. So this is our starting point. And then where do we stop? 1, 4. So 1 on the x, and then up at the 4 on the y. 1, 2, 3, 4. So the question is, how do you go from this point to this point right here? How do you go from here? Well, you have to go 1, 2, 3, 4. You have to go 4 units to the right. 4 units to the right. And then you have to go up how many units? 1 unit up. 1 unit up. Okay? So we have a quadratic function right here. If we shifted 1 unit, 4 units to the right, and 1 unit up, we're going to have another quadratic right here. Okay? So just by using the vertices, we can basically predict exactly what's going to happen when you shift the functions. Okay? So there goes your answer. 4 units to the right and 1 unit up are the shifts from this function right here to this function. Okay? So that's that. So thanks so much for taking the time to watch this video. Please subscribe to my channel by clicking up here so you can get updates to future clips such as this. You can also share the contents of this video via Facebook or Twitter. More videos can be found on my TrU1.com. Thanks again and have a wonderful day.